Yeah, let's start.
Okay, sir. Fine. So, good evening, everyone. So, I welcome you all to the new session on solving previous year gate questions. So, last class we focused on solving questions which are asked in the year 2009. So, today we will focus on the questions which are asked in the year 2010, which is the fourth edition of the Gate Aerospace. Okay. So, my name is Praveen, and let's get started. So, this is the first question. So before that, again, let's see how many number of questions were asked. So a total of 10 questions were asked, out of which there were 4 1-mark questions and 6 2-mark questions. A total of summing up to a total of 16 marks. So basically, like I said, the range would lie in between 16 to 25 marks. So expect no more, no less. So you'll have questions which are in this range. Okay, right. So let's get started. So this is the first question. An aircraft is climbing at a constant speed in a straight line at a steep angle of climb. The load factor it sustains during the climb is, there are 4 options: equal to 1 point, greater than 1, positive but less than 1, dependent on the weight of the aircraft. Okay, so let's see how to do this. Pretty simple. So it says it is climbing at a constant speed. Okay, so let's consider an aircraft, some fighter, a steep angle of climb. Steep angle of climbing, the angle of climb is very large. Okay, so this angle. Okay, basically, so what will be my lift forces will be, weight will be acting again vertically. So this will be the lift. If this is gamma, then this will also be gamma. Right. So if I resolve, so this will be my lift, this will be my drag. If I resolve the forces in the vertical means in the lift direction. So if I resolve this, so you have L equal to W cos gamma, isn't it? So which means what? I can say that cos gamma is equal to L by W, right? But what is L by W? That is basically my load factor, right? Yeah. But you know that cos never exceeds 1 and never goes below 0, right? So which means, this n value lies between 0 and 1, correct? Which means, so our load factor is positive, always positive, but it is less than 1. So the answer is option C. Hope everyone understood this, right? Okay,
Notation you have written.
Yes, sir. But is it again loading, sir? I mean, I'm
No,
seeing
no,
in the
no. Now
video.
it will work. Now it will work.
Okay, fine, sir. Yeah. Because if there is network issue, means you can't hear me. That's why I say. Let me
No, no,
erase
no,
this.
no. It was issue from server side, not from you.
Okay, fine. Fine. So let me just explain this. Let me go to the next slide and then let me explain this. What we just seen in here. Right. So what is given in here? So all of the factors remaining constant. If the weight of an aircraft increases by 30%, then what will happen to the takeoff distance? Right. That's what is given. So let's try to do that. So we know the formula, right? Let me recap because of some net issues. So I have S is basically 1.44 WTO square by rho GS CL max times T minus D minus mu times W minus L, right? That's what is given in here, correct? Which means that all other factors keeping constant, right? So which means T, D, L, S, C, rho G, everything constant. So which means all factors are kept constant except W, right? So which means I can say that S is proportional to my WTO square, correct? Right. So which means, yeah, I will come back to the first question. Just Bear with me, okay? Just copy this one and then I'll go back, okay? Right. So which means I can say that my S2 by S1 is simply equal to W2 by W1 to the whole square. What is saying is if weight is increased by 30%, so which means what? W2 is 1.3 times W1. Substitute it in here, you will get what? 1.3 W1 by W1 to the whole square. So this will give 1.69. So which means what is the percentage increase? Is 69%, right? Simple decimals, right? So hope this answer is sufficient, right? I mean, so going by this, my answer comes out to option C, which is very close. Okay. Right, so which means what? I mean, heavier the aircraft, you need a larger, longer runway, to take off, right? That's why if you take the commercial airlines, and they're basically low-wing aircrafts, they will require a short distance, whereas cargo airplanes are high-wing aircrafts, and they require a much longer runway to clear. Okay, because they have much heavier weight to carry, right? So this is the case. Okay, right. So let's go back to the first question of today's session. Yeah. So let me repeat again here what we just did it in here. An aircraft is climbing at a constant speed in a straight line at a steep angle of climb. The load factor sustains during the climb is, so we have four options: equal to 1.0, greater than 1, positive but less than 1, dependent on the weight of the aircraft, right? Yeah, I'll come back to the same question. Ajinkya, just bear with me, okay? Let me explain this again. So when aircraft is in takeoff, so it says at a steep climb, right? So which means this gamma is large, right? So if you resolve the forces, my L would be equal to what? W cos gamma, right? So which means what? What will be my cos gamma? Cos gamma is simply L by W, right? What is L by W? We know by definition L by W is the load factor, N, right? And this N, for cos gamma, it lies between 0 and 1. Hence, we can say that N cannot be negative, right? So which means these options are ruled out, but it is positive and it is less than 1. Okay, so this is the case. Hope you guys understood this, right? So please free to post questions in the chat box and respond it to it. Okay. So let's go back to the second one. Okay. Um, so this is the formula again. So let me just reiterate what I said. So this is the formula in here. So the S is proportional to the W square. Okay. So which means this is what I've did it over here, right? So you can see S is proportional to W square. So which means S2 by S1 is W2 by W1 to the whole square. I can rewrite this as 1.3 W1 by W1. Why 1.3? Because weight is increased by 30%. So which means what? The new weight will be 1.3 times the original weight, right? So that's what I have written over here. So substitute it back in here. So you get 1.3 W1 by W1 to the whole square. So you get it as 1.69. And what is the percentage increase from basic math? It's 69%, right? So which means what? So the percentage increase is now 69%, which is option C, right? Hope you guys don't have any doubts, right? So let me go to the next question. An aircraft stalls at a speed of 40 meter per second in a straight and level flight. The slowest speed at which this aircraft can execute a level turn at a bank angle of 60 degrees is dash. So we have four options: 28.3 meter per second, 40 meter per second, 56.6 meter per second, and 80 meter per second. So let's underline some keywords. Stalls at a 40 meter per second in straight and level flight. The slowest speed at which the aircraft can execute a level turn at a bank angle of 60 degrees, right? So this is the thing. So let's try to understand this again. So we know that what is my stall speed, what is my speed formula generally? Let me write in the next slide. Okay. So generally, I'll come back to your questions later and just bear with me. Okay, let me just finish this. So the stall speed is basically what? It is under root 2W by rho SCL, right? This is what is the definition, right? And the value given it as 40 meter per second, right? Let's use a subscript V star, okay? And he's saying at level turn, my bank angle is 60 degree, right? So which means what? From the formula, the load factor is simply 1 by cos phi, which is 1 by cos 60 which is equal to 2. You can refer to this formula in JDA aircraft performance. Okay, JD Anderson performance. Okay, please refer into that. Right. So once we determine the load factor, so my stall in turn, the stalling velocity, this is the slowest speed, in turn. That would be what? It is simply root of n times the v stall. Okay. So which means what? It is basically root of 2 times 40. And this gives out a value of 56.6 meter per second. This is my required answer. And the option closest to this is option C. Okay. Hope you guys understood this. So please refer to JDA if you have any further doubts. Okay, because most of the questions which are asked in GATE are direct execution. Basically, you have to substitute a formula and then get the results. Okay. Right. So let's go ahead to the next question if no doubts. The absolute ceiling of an aircraft is the altitude above which it. There are four options: can never reach, cannot sustain level flight at a constant speed, can perform accelerated flight as well as straight and level flight at a constant speed, can perform straight and level flight at a constant speed only. So absolute ceiling underlines the word. Okay. So let's try to understand what is this absolute ceiling. Okay. Fine. So in aviation parlance, we have two altitudes. So this is basically my H versus V plot. So we have two ceilings. So one is my service ceiling, another is my absolute ceiling. So service ceiling is where your rate of climb is limited. Okay, so your R by C is limited to some finite value. Your absolute ceiling is the height at which your R by C equal to zero. Right? The rate of climb is zero, which means that let's say you are just 1 meter or let's say 10 meters far away from the absolute ceiling. You are flying a fighter. Okay, some Sukhoi Su-30. You're flying. So now when you're flying it, let's say you're increasing the incidence angle, so which means aircraft will not go up. So it will cross this absolute ceiling, but basically what will happen is your wings will start vibrating and there will be so many fluid structural, acoustic instabilities coming in and structural instabilities coming in. So many effects come into the picture, right? So which means what? It can basically cross this, but it cannot sustain, okay, a level flight. So which means what? If I go back to the definition, so it cannot sustain level flight at a constant speed. Okay, so this has to be the definition. So it can reach up beyond absolute ceiling, but with a lob and with structural instabilities coming into the picture. Okay, so this is an important thing, and it can never perform accelerated flight at beyond the absolute ceiling because, like I said, you will have issues, and it can perform stable, and this is also not possible. So the only answer is possibility is option B. Okay, hope you guys understood this. And please, if you like this session, please put a thumbs up in the chat so that motivates me to do more sessions like this. And I'm happy to clarify any of your questions. Right? Okay. So let's go to the next question. If you don't have any doubts, a propeller-powered aircraft trimmed to attain maximum range and flying in a straight line travels a distance r from its takeoff point when it has consumed a weight of fuel equal to 20% of its takeoff weight. If the aircraft continues to fly and consumes a total weight of fuel equal to 50% of its takeoff weight, the distance between it and its takeoff point becomes 2.5 r, 3.1 r, 2.1 r, and 3.9 r. So again, this is a pretty easy question, but you have to think about it. Okay, right. So let's try to do this. So let's underline first several keywords. So trimmed to attain maximum range and flying in a straight line travels a distance r from its takeoff point consumed weight of fuel equal to 20% of its takeoff weight. If the aircraft continues to fly and consumes a total weight of fuel equal to 50% of its takeoff weight, the distance between it and its takeoff point becomes okay. So let's try to do this. Pretty simple. So by definition, the range for a propeller engine is basically eta P by C, CL by CD, ln of W naught by W1, right? So where C is my specific fuel consumption. And eta P is my propeller efficiency. And CLCD obviously know it's lift to drag ratio, logarithmic of the original weight to the weight after it has consumed fuel and also okay. Right. Which means let's do this situation one by one. He says when 20% of weight is consumed, right? Is consumed. So my expression, this one alone, would become what? Ln W naught by, because it is consuming 20%, so the remaining mixture will be what? 80%, right? So that can be written as 0.8 times W naught, right? Let me repeat again, because it has consumed 20%, remaining is 80%, so that's why I'm putting a 0.8 in here, right? And all these terms are constants, right? So which means, let me write this as, R would be equal to some Z, okay? Z times ln of W by 0.8 W. So this will give you a value of 0.223 Z, okay? This first. Next is when he's saying that 50% of fuel is consumed. 50%, I mean, when fuel is consumed, which is equivalent to the 50% of the takeoff weight, okay? That's what is the meaning, okay? So what can I say? My R would simply be what? Z times ln of W by 0.5 W. That will give you the value of 0.693 Z, right? Now, what is my Z? So let's bracket this first. Sorry. So you have this one and you have this one, right? Now, mind you, now we are consuming, so which means now this will be a different distance, right? So let's use some one notation in here, okay? So let me go back to the question again. See, it travels a distance r from its takeoff point when it has consumed a weight 20% of its takeoff weight. Okay, so this part is done. If the aircraft continues to fly and consumes a total weight of fuel equal to 50% of its takeoff point, the distance between it and its takeoff point becomes. So, which means what? If I try to solve this in here, so basically I have to divide this, right? So, which means my R1 by R would simply be what? 0.693Z by 0.223Z. So that will give you closely of 3.1. So which means what? My R1 is 3.1 times R. Hope you guys understood this, right? So let me repeat what we did it in here. So let's rewind. So first the range formula is known, okay, for us. So this can be again found in the performance book, okay. So all the parameters are constant except for the weights, okay. So when you consume 20% of the weight, so you have to substitute. I mean, obviously, it's so the remaining weight will be 80%. So you substitute it in this expression, you will get Z because we keep all this constant, all these parameters as constant. So let's replace them by a constant which is Z times logarithm of W by 0.8 W, and that will give you a value of 0.223 Z. Okay. Now, when you consume 50% of the weight, so my distance now becomes Z times ln of W by 0.5 W, and which turns out to be 0.693. If I divide these two, you'll get a value of 3.1, and that is basically the total distance which is consumed. Okay. So my answer is 3.1. Hope you guys don't have any doubts in this. And let's go to the next question. An aircraft is cruising at an altitude of 9 kilometers. The free stream static pressure and density at this altitude are 3.08 into 10 power 4 Newton per meter square and 0.467 kilogram per meter cube respectively. A pitot tube mounted on the wing senses a pressure of 3.31 into 10 power 4 Newton per meter square. Ignoring compressibility effects, the cruising speed of the aircraft is approximately dash. So we have four options: 50 meter per second, 100 meter per second, 150 meter per second, and 200 meter per second. So let's underline static keywords. It's cruising at an altitude of 9 kilometers. At this altitude, your static pressure is this and your density is this. A pitot tube senses a pressure of 3.31 into 10 power 4. Ignoring compressibility effects, the cruising speed of the aircraft is approximately this. Let's try to do this. Pretty simple. So let's write the given data first. So at an altitude of 9 kilometer, my pressure is 3.08. The static pressure, okay? 10 power 4 pascals or Newton per meter square. My density is what? 0.467 kilogram per meter cube. What about my. So he says a pitot tube mounted on the wing, okay? So what does a pitot tube measure? So a pitot tube measures, the stagnation pressure. This is very important, okay? So pitot tube measures stagnation pressure. Which means what? So my P naught is basically 3.31 into 10 power 4 pascals, right? So it says ignoring compressibility effects. Okay. So if we ignore compressibility effects, so what equation should we use? So we have to use Bernoulli's equation. Bernoulli's equation will become applicable, okay, at that point. Which means what? My P naught is simply P plus half rho V square. Substitute that. So I have 3.31 into 10 power 4, which is equal to 3.08 into 10 power 4 plus half times 0.467 V square. If you solve this, you will get V as 100 meter per second. Bracket this, and the correct answer is option B. Hope you guys don't have any doubts in this. Again, like I said, the questions may seem daunting, but at the end, it's basically simple. Basically by doing certain steps, we can basically arrive at the answer. Okay. So fret not. Please feel free to ask any questions. Let's go at the next question. If you don't have any doubts, the trim curves of an aircraft are of the form CMCG equal to 0.05 minus 0.2 delta E minus 0.1 CL, where the elevated deflection angle delta E is in radians. The static margin of the aircraft is dash. I have four options: 0.5, 0.2, 0.1, and 0.05. So let's try to do that. So underline this expression CMCG, static margin is asked. So by definition, static margin is basically the difference between the distances of normalized distances of neutral point and the CG. Okay. So which can be basically written as it is basically minus dou CM by dou CL. So this is basically the formula for the static margin. Okay. So please remember this. Which means let's differentiate this expression. So above expression. So I have dou CM by dou CL is basically minus 0.1, right? Differentiating this, which means what? static margin is minus of dou Cm by dou Cl, and that is equal to 0.1, right? Hope you guys understood this. So hence my answer is 0.1. Very simple, right? So questions in stability are very simple. So you can just answer it. No, it's very just answer it in a fraction, a matter of seconds. Okay. So please be careful while doing problems like this. Okay. As you tend to make mistakes in these problems. Right. So let me go ahead. So look at this question. The trim curves of an aircraft are of the form CMCG equal to 0.05 minus 0.2 delta E minus 0.1 CL. Same value, okay, same expression for CM, where the elevated deflection angle delta E is in radians. The change in elevated deflection needed to increase the lift coefficient from 0.4 to 0.9 is dash. So underline this thing, the change in elevated deflection needed to increase the lift coefficient from 0.4 to 0.9. So let's try to do that. Very simple again. So given that CMCG equal to 0.05 minus 0.2 delta E minus 0.1 C, right? Okay. So which means he says the change in elevated deflection need to increase lift coefficient, right? So he says trim curves, right? So at trim we know that. So underline this for trim. At trim, my CMCG is zero effectively, right? Trim is basically the point at which your net moments are zero, right? So which means let's substitute that. So I'll have what? 0.05 minus 0.2 delta E1, let's say, minus 0.1 CL1 equal to 0, right? Which means you can write another sense as 0.05 minus 0.2 delta E2 minus 0.1 CL2 equal to 0. So these are the two equations, right? So which means what? My CL1 is 0.4 and CL2 is 0.9. So we substitute it back into this equation, and simplify this and get the delta E, my delta E2 minus delta E1, right? Solve this, okay. So solving the above equation to get delta E2 minus delta E1, okay. So you can do that in a simple math. So you will get that value as delta E2 minus delta E1 as minus 0.25 radians. So bracket this again. So this is my required answer, and the answer is option B, which is minus 0.25. Clear? Hope you guys don't have any doubts in this. Right. So if no doubts, let me go to the next question. So we have linked questions. So these two questions will be our last questions for today. An aircraft is in a straight and level flight at a constant speed v. It is disturbed by a symmetric vertical gust, resulting in a Phugoid oscillation of time period t. Assuming that g is the acceleration due to gravity, t is given approximately by option A. We have four options: v by pi g, option B pi v by g, option C v by root 2 pi g, and option D root 2 pi v by g. Okay, so let's again do this. It's simple straight away formula. So he's saying that it is disturbed by a symmetric vertical gust. That's one thing. It results in a Phugoid oscillation. Okay. So Phugoid is basically where your time period is large, so which means my angular frequency is low. Okay. Just let me go to the next slide. So in Phugoid, I can write it down. My time period is large. That is time period to attain equilibrium, right? Basically, this will be the plot. Okay. It will take much longer time. Let's say the aircraft is somewhere here. It will take longer time. So it means my omega as given by the derivation, if you could refer RC Nelson, it's simply root 2 times g by v. Okay, so this is the expression for the angular velocity in a Phugoid mode. Okay, so it means what? I can write the time period as 2 pi by omega, right, in Phugoid. So which means I will have root 2 times pi v by g. So this is my resulting expression that I have from the Phugoid. So answer goes down here to root 2 pi v by g. Copy this, guys. Hope you guys don't have any doubts in this. Right. So let's go back to the last question, which is question number 55, which is again a linked question. If v equal to 200 meter per second, then the wavelength of the Phugoid oscillation, assuming g equal to 9.81 meter per second square, is approximately. So we have four options: 1.28 10 per 4 meter, 1.30 10 per 3 meter, 1.81 10 per 4 meter, and 918 meter. So we have four options, right? So let's try to do this again. Simple problem. So let's write the given data. What is given? V is given as 200 meter per second. And what else is given? G is given as 9.81 meter per second square. So recall, as I drew earlier, this is a Phugoid motion basically. This is basically the amplitude. Okay, how much it has displaced by the vertical gust, right? So what is the wavelength in here? So can I write the wavelength as what? Wavelength is basically distance, right? The distance traveled by the wave, right? So this is one wavelength, right? So I can write the wavelength as speed with which it propagates times the time period. Can I write it like that? Yes, right, I can write it right. So which means what? V is the velocity times time period. We just derived we just knew the expression for that. It is root 2 times pi v by g. And if you substitute that, so we'll have what? Root 2 times pi v square by g. And if you substitute all the values in here, so root 2 times pi times 100 square by, sorry, I mean 200 square by, so 200 square by 9.81, right? So this is my lambda. And if you solve this, you will get a value closer to 1.81 into 10 to the power 4 meter, right? So this is the required wavelength, and the option that corresponds to this is option C, right? Hope you guys have copied this and you don't have any doubts in this. Okay, guys, so that's it for today. We have covered 10 questions which were asked in GATE 2010, and feel free to put any questions in the chat box and I will be happy to help you. And that's it from our side. And thank you for attending today's session. And I wish you, all the best for appearing, for doing well in your GATE exams, right? Okay, guys, see you. And the floor is open to questions. If you have any doubts, please ask me.